Hello everyone, welcome to solve this nice math Olympiad algebra problem. So here we have x squared divided by 25 is equals to 25 divided by x squared, and we solve this problem for all the values of x. So here first we need to find all the roots of this equation, and at the last we will be verify that which of the roots are solution and which of the roots are extraneous root. And now we move towards the solution of this problem, and here the very first step we are going to do is first we need to cross multiply the terms, and we multiply 25 with 25 and x square with x square, and we get x square times of x square is equals to 25 times of 25. And here we first rewrite this equation as x square times x square equals to, we write 25 as 5 square times 5 square. We know that 25 is equals to 5 square. And here we use the nice algebraic formulas, and you know about that. If we have a to the power of m times a to the power of n equals to a to the power of m plus n. According to this rule of exponents, we just write both of the sides of this equation as. So you see that the bases on these two terms are same, so we add its exponents and we get 2 plus 2. In the same pattern, you again see that the bases of these two terms are also same, so we write it as 5 to the power of 2 plus 2. And now in the next step we have x to the power of 2 plus 2 becomes 4, and 5 to the power of 2 plus 2 is also becomes here 4. And in the next step we move the term 5 to the power of 4 from right hand side to the left hand side, and we get x to the power of 4 minus 5 to the power of 4, and this whole equation is equals to 0. So you see that after this little bit simplification, we convert our given question statement into the fourth order equation. This means that this equation has 4 or less than or equals to 4 roots. We need to find all that 4 roots of this equation, and at the last we verify that which of them are solution and which of them are extraneous root. So here we rewrite this equation as, this is x to the power of 4, we write it as x square and its whole square minus, this is 5 to the power of 4, we write it as 5 square and its whole square, and this equation is equals to 0. And now in the next step we use here again another algebraic formula. You know about that. If we have a square minus b square equals to a minus b times of a plus b. According to this, you see here the base of this term is our a and the base of this term is our b. So according to this formula, we expand the above equation as x square minus 5 square times x square plus 5 square, and this whole equation is equals to 0. So here we again apply the above algebraic formula into the first factor, and this will be written as x minus 5 times of x plus 5 into x square plus 5 square, and this whole equation is equals to 0. After that, we divide this equation into the three cases. The first case is we write x minus 5 is equals to 0. The second case is we write x plus 5 is equals to 0. And the third case is we write x square plus 5 square is equals to 0. From here, we move the term minus 5 to the right hand side, and we get the value of x is equals to plus 5. And from here we move the value plus 5 to the right hand side, and we get the value of x is equals to minus 5. And now in the next step we get x square plus 5 square is equals to 0, and we obtain x square is equals to minus 5 square. So here from this case we need to get the values of x, and for this we apply or we take square root on both of the sides, and when we take square root this will becomes here in this form. And again you see that these 2 and square root are gone, and we get x is equals to, here we apply square root separately on both of these two values in this form. And now in the next step, these 2 and square root are gone and we get 5, and we know that square root of -1 is equals to iota. Further, you see here we apply square root on both of the sides, so that we write here plus minus sign on any one of the side. So these are the other two complex roots of the given equation, and from above we have x is equals to plus minus 5 be the two real roots of the given equation. So finally we have these are the four roots, and now in the next steps we need to verify that is these roots be the solution or is these roots be the extraneous roots. So for verification of this, we need to copy down given question statement. Here it is x squared divided by 25 is equals to 25 divided by x squared. So further in the next step we first substitute this value of x on both of the sides, and we get plus minus 5 squared divided by 25 is equals to 25 divided by plus minus 5 squared. Similarly, we substitute this value here and we get plus minus 5 iota square divided by 25 and 25 divided by plus minus 5 iota square. So in the next step we have, you know about that the square of a positive or negative term always gives us positive answer. So plus minus 5 square becomes 25 divided by 25. In the same pattern, 25 divided by again the square of plus minus 5 becomes 25. From here you see that the square of plus minus 5 becomes 25, and the square of iota becomes iota square divided by 25. And in the same pattern we have 25 divided by again the square of plus minus 5 becomes positive 25 into iota square. And now in the next step here we need more simplifications to verify these values. You see that this 25 and this 25 are cancelled out by each other and we get 1. From here this 25 and this 25 are gone and we get here 1. You see that both of the sides are equal. It means that the value x is equals to plus minus 5 is satisfied our given question statement. And in the same pattern this 25 and this 25 are gone, and from here we get iota square. Further, we know that the value of iota square is equals to -1. This 25 and this 25 are also gone and we get 1 divided by iota square, and iota square is equals to -1. So we have -1 is equals to -1. This shows that both of the sides are equal. It means that all four roots of the given equation satisfied our given question statement. So finally we have the solution set of the given question is plus minus 5 into plus minus 5 iota. So this is our final answer of this question, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.